Welcome to my channel. Okay, it's working. So basically I'm just exploring today. I was reading yesterday Nix builds system key layout. Today, maybe I'll just read a bit Nix builds, but I've had my eye for a while on this infinisil's system repository, my system configuration. So I wanted to kind of work on my also configuration.nix. And I only have one file, right? So all I have is right, I have only one file. Actually, everything's right. Everything's defined within one module. And I wanted to kind of work through understanding this function. He has this function, and I had my eye on this function. Imports default.nix. So he always writes default. Okay. So this is, I guess, because Nix will immediately pick up a default.nix. If you evaluate something in a directory and you call it actual default.nix, it immediately, like you don't have to pass in the name of the file to evaluate. If you have a default.nix, this is the first file that gets evaluated. So today I'm kind of studying his configuration. And there was a nice thing I told him I would cover that, yeah. So it's kind of a cool thing. So he uses, he uses Vim, okay, but it's same thing. If you want to use escape, okay, wait a second. So I think I mentioned this yesterday, but I want to kind of implement it today. So makes caps lock backscape, caps as backscape key, repeat work in X. Not sure what I'm going to do with this because I'm on Wayland. But he uses caps for escape, which is cool. But that's not the brilliant part. The brilliant part is, no, he uses caps as backspace. What am I saying? Caps as backspace, which is really nice. And I remember Steve Yege had this. Steve Yege, there was an old Steve Yege, wow, yeah. I used to read his blog. Steve Yege had this Emacs backspace. Effective Emacs. Yeah, effective Emacs. This was a famous blog spot. So, backspace. Look at this. Prefer backward kill word over backspace. That's interesting. Emacs wizards try to avoid hitting the backspace key because it's just remote enough from home row to be annoying. Right. We make dismiss. Oh, Depst, I was talking about langdev. Hi. I was talking about langdev in one of the Discord servers I'm in, and someone brought up functional programming, FP. And I thought sometime I'd maybe be cool to make some kind of lambda calculus interpreter or compiler. What kind of features would you like in one? Oh, I don't know if I'm the best. Like, what do you mean? Because first of all, you got to understand what's lambda calculus about. That's what I'm trying to do also with Nix. Like today I'm going to look into this function that traverses through the directories, but it's written in a functional way. So the features would be first, just doing the basic lambda, lambda calculus, like what we did with the book that I was going through, I only got to the booleans and then church numerals where you define numbers. So I guess first you gotta understand. Yeah, I'm not sure what you mean by features. What do you mean by features? What does it mean to you when, in this context? What kind of features would you like in one? Yeah, because it's a lambda calculus interpreter is, yeah, I don't know. Yeah, I don't know what you mean. Yeah, I'm completely ignorant when it comes to lambda calculus, so I wasn't sure if there's any features that may be really helpful. Like C++, there are features like templates and methods. With Rust, you got things like pattern matching and other features. Yeah, but with lambda calculus, you gotta understand first what's the point of it, because like with Nix, it's a language, but it's not just for packages. In the sense they don't touch things. They don't touch things. I mean, all in functional programming, these functions have a way they relate to one another. So when you say like methods, well, it all boils down to how functions connect, how they, like templates, you see, that would be way too complicated, I guess, you know. I think the best thing would be to first to implement, or even to go through some book that, and see how much you understand. Like that book that I was going through, I think that would be a good start, right? Lambda calculus, what was it? Functional programming, PDF, what, lambda calculus. I mean, you have YouTube videos and such, but you could just read through this actually, at least, and see. You gotta see, because it's a whole different mindset of how you think about programming, and I mean, like, it's almost like a different way how you make sub modules out of your ideas, and making tiny building blocks that connect. Also, one great video, I love that video. I don't know if you like it. It would be nice if we could just watch this video. I'm serious. You should check Brian Beckman. Brian Beckman is like a legend. The best of Brian Beckman. Did I make Brian Blade? No, I'm sorry. Wait a second. Beckman, functional program. Wait a second. Always Brian Beckman. Look at this. Don't fear the monad. Or like this. Look at this. The Zen of stateless state. Okay, that's like if you really want to, like, this might be for you. Well, I'll stop this. This might be for you. Don't fear the monad. So, Brian Beckman, he's really cool. I wonder, like, I don't know if you have time for this stuff, but this is really a nice talk. I sometimes watch this talk after, like, every year once. Not really every year, but I come to it, you know, back and forth. When was this? 2012. Cross posted from Channel 9. So this is really great stuff. Maybe because he will try to define using C# some at the beginning, but he will kind of explain what's the point of combining functions. And I think this would be helpful, you know, this because it's just a one talk, but it's very interesting. And then he goes forth, and then he defines what's a monad at the end. Right at the end, when he defines it, I kind of lose him there. That's the part where I keep re-watching a bit, but you could try it out. Yeah, it's just a recommendation. And he has a nice way of talking about these things. He's kind of, I don't know if you know about him. Also, this is another brilliant Eric Meyer. You know, he has a whole Eric Meyer, Haskell 101. Look at this. Yeah, okay, but that's different. You don't need that. Category theory, the essence of interface-based design. Yeah, you don't need that now, but I guess you could check that Beckman talk. This is really cool stuff, you know. Anyway, I went a bit off. Sorry. But I would just do really basic stuff with lambda calculus and see how it works. You know, you just gotta see how the things connect. Right? Because if you want to define it, you have to know how it works. I guess that's what I kind of missed when I was building Lisp, because I didn't really understand. I kind of did, you know, but a bit. But it's just, I was thinking of rebuying this book that I gave away a long time ago. What do you mean? That's the book I just sent you. Wait, that's the book here that I just sent you. It's just this one has the cover. That's the same book I just sent you. This book, look at it. It's the same book. Well, that's the book I was going through in my videos, like those 22 videos. That's the book I was going through. You were there. I think we even mentioned this, you know. Well, you can rebuy it or you can just read it. You know, there is, of course, if you like buying books, I know. It's nice to have some computer books. Like I have some nice books. Haskell books I have. Some books I gave, but I have like 2 Haskell books. They are like there. It's funny. Okay. So I was trying. ChatGPT is not bad in explaining stuff. Where is it? System. So this is his system configuration. Unlicensed license. This is also interesting. I never put a license. I think I would wait, what am I going to do about this? Yeah, also one more thing. I was reading this when you came. Yeah, Steve Yege. Global set key, backward kill word. Backspace, backward kill. I have some nice systems programming books in C++ and Rust books. Just my books on LangDev and OSDev cost me like $500. But the payoff is I'll be educating myself more than a semester of school for $700 for one class, one term. Ciao, good morning. I usually using MIT. What's MIT? LI? Like open courseware? But this is interesting. How would I implement? This is an old blog. I don't know if you guys know about. Do you guys know about Steve Yege? He was very famous. I think he still is. Oh, look at this. You might like this, Depster. Effective Emacs. Anyway, he's talking here about some tips on, I don't know if you know about Steve Yege. MIT license. Oh yeah, MIT license. Yeah, I saw that. People put MIT license. But he put here unlicensed license. That's for his configuration. which is interesting. So unlicensed is like there is no license. I kind of like that, just for the, you know, like something as plain as configuration. Unlicensed, set your code free. Managing your repositories, setting and features, customizing your repository, licensing a repository. Yeah. So public repositories on GitHub are often used to share open software. You'll need a license. You'll need to license it so that others are free to use, change, and distribute the software. Yeah, actually, it's more like that, right? I have to use a license. Otherwise, it's, we created choose a license. Choose a license. I want it simple and permissive. I need to work in a community. I care about sharing improvements. My project is in software. I don't want to choose a license. MIT, but why? So what's the unlicensed? The MIT license is short to be to the point. It lets people do almost anything they want. Yeah, but I don't like. Okay, what's the difference between the MIT license and unlicensed? Unlicensed. Permissive but with conditions. Allow reuse even in proprietary. Requires attribution. Denies warranties and liability. Do whatever you want, just give me credit and don't sue me. Okay. Unlicensed, completely. This code is completely free, no strings attached. Controversial and less widely adopted, some countries don't allow full abandonment of rights, so its legal effectiveness varies. Oh, interesting. Look at this stuff. Includes fallback license. If a country doesn't recognize public domain dedications, it includes MIT-like terms. Oh, I didn't know this. It has a fallback license. You're not legally required to credit the original author. Interesting. Yeah. So, what was I doing? Where's Steve Yege? Steve Yege, yeah. Swap caps lock and control. Right. On Windows, the control key, yeah. So I've texted in infinisil, and I was first confused because he has caps lock as escape. No, he has caps lock as backspace and control as escape. So then I was confused, like, how do you do left control then? But he has a tapping mechanism. What do you call it? Tapping left control is escape. I have to somehow implement this. So tapping left control is escape. And holding it is left control key. Interesting. So you hold it. Look at this. 200 milliseconds, and it's left control, and it's escape, and more than that, I guess it's left control key. So I wanna. That'd be nice. But is there a way to implement? Yeah, I'll just try it like this. Anyway, wait a second. So is there a way to implement here that backspace, or so we mapped caps lock to backspace. Is there a way to make the backspace delete the whole word instead of just going back a character? Yes, you can map caps lock text that deletes the whole word. Wait. You're already using advanced tool. Like, I wonder if interception tools to make caps lock already map to backspace, delete whole words, act like control backspace. You'll need to slightly extend your setup. Interception tools plus custom plugin. You can use caps to escape plugin for custom plugin like mod tab. Use a dual function key when tapping caps. Add caps lock to your udev. Add a tap action that sends control backspace. No, I want backspace to delete the word. I don't want to have a combination of sorts. To behave as delete whole word with a single key press, no combos. In both Linux console, there's no native delete whole word key code, but we can work around that. Yeah, to do this in Windows 2000, look at this. Then was Steve was saying that how to delete the whole word. Interesting. Map caps lock to a fake key plus auto trigger control backspace via xbind. We simulate that pressing a single key, caps lock, triggers the action of control backspace using, well, then maybe it will be funny that caps lock, you press it once. Interception tools. Wait a second. Interception tools. Services interception tools. We could check that out. NixOS options. So services interception. Services interception tool enable plugins. I'm not sure which one. Now what am I looking at? Remap caps lock. Use xbind step by step for X11. Install dependencies. Okay, this is like a fix or something. Tapping left control is escape. Services interception enable udev let dual function keys config. Yeah, but I want to add this somehow to this part of the code. I'm looking now through NixOS options of this setting to see how to enable it. Extension interception tools. What are interception? What are interception tools? Archwiki. Many plugins are available. Interception caps to switch caps lock with control. To modify the behavior of a key when held. Dual function keys. Oh, that's it. But yeah, I can't find what you're looking for. Interception dual function keys. kernel libdev. Yeah, I don't know if there is, maybe there is something like this in Helix. Backspace word. Deleting a word with the backspace key is typically done by pressing Control backspace. Oh, it's just Control backspace. You can use Alt backspace, which has a similar function. So that means I have now Control delete in a word. Yeah. I'll lose a lot of time now in thinking what to do here. But how did he introduce, so this is the key layout, .nix. This is a module, submodule, right? That is only about keys, about the key layout. So he didn't put the actual layout here. No, he did. Console use xkb config. True. Okay, first of all, I gotta see how am I gonna, because I still have to use, sudo. I should keep it in my home directory. Yeah, okay, how do I edit, my configuration.nix? But I'd like to, work on it in my home directory so that I don't have to use sudo. What's the best? I know there were several ways how people deal with that. I'm going to check now on Discourse. Maybe you could go on NixOS Discourse, and they've covered that. So having your personal configuration in your home directory, what are some of the ways I could do this? Many NixOS users want to manage their system configuration from their home directory without needing to sudo every time, right? Rapid iteration backups and general ergonomics. So there are a few common approaches, right? Ways to manage flake-based. That's one thing. I do want to try flakes, but just try it. And then having the modules like flake parts. That's one of the things I'd like to see how it works. You only use sudo for NixOS rebuild, not editing files. Is now semi-official. Oh, interesting. This from the manual. Sec flakes. Really? Where did you see this actually? Flakes, NixOS rebuild. Well, this is what I do sometimes, but look at it's You can run the whole command as root while preserving user environment variables by prefixing the command with sudo -e. That's what I do. But this method may create root-owned files in home cache if Nix decides to use the cache during evaluation. Do I have that? Let's see NixOS modules. Yeah, it didn't really find links. Wait a second. Pros needs slight learning, symbolic links. Yeah, a quick and dirty solution. Still needs sudo for rebuilds, not flake based. Use NixOS rebuild wrapper from home with flake. No, add a shell alias. Recommend folder structure inside your NixOS config. Hosts your hostname, modules, home. This is not bad. Then your flake Nix can import the right pieces like so. Description, my NixOS configuration. Flake template. Ah, okay, this thing we can read. Twigs flakes for NixOS. What's this? Twig. Since you're already deep in Nix, use a flake in NixOS config and point NixOS rebuild to it. Yeah, this is Nix config. So we're just looking through config. I used to have the configuration from Volpe. From Volpe actually. This thing. He used to have xmonad. That's what I had. Look, 950 stars, 80 forks. NixOS configuration. Nix config. Yeah, this is Nix config. My current and always evolving NixOS and home manager configurations. This would be nice to have. Look at this, built with Nix home passing. He has a CI. And this is it. The Wayland kid on the block. Hyperland. Nice. Yeah, I kind of like this. It would be nice. But what did he do in environment details? Okay, editor, launcher, shell, waybar, has a waybar, foot, hyperland, Juno, ocean, beautyline, terminal font. It's funny, some of these devs over the years, they use the same fonts. Like Tsoding uses Ioshevka, but he didn't use it before, like 5 years ago. Anyway, it's just... Oh, cute. GIF quality. Expand to see xmonad will be forever in my heart. The best Windows manager. The best X window manager. Yeah. xmonad is nice. It was a nice. I used to have this setup. Environment details. Expand to see more. Structure. So let's look at his structure. Wednesday. Okay, so flake.nix, lib, overlays, packages, outputs, outputs. So there are two outputs. What do you mean two outputs? HM, Nix, Home Manager, VM Hyperland, VM Xmonad. So he can switch to Xmonad also. Outputs, os.nix, host, Dell. So he has 3 laptops still. And host Xmod. What's Xmod? And expand to see available outputs. NixFlake show GitHub apps, home configurations, Hyperland, Hyperland, Hyperland. So it has a different Hyperland configuration out, as well as all declare Flake inputs. NixFlake metadata, further installation instructions. Let's check this out. Would be nice to try it out, like in a VM also. The Xmod configuration also contains my home manager configuration using the NixOS module, so it can easily be tested with a single command. Yeah, I don't know what will happen if we do this. Or you can test it directly on a QEMU virtual machine, though it has its limitations in terms of graphics. Like, look at this. If we just do this, I wonder what will happen. Let's try it out. This is one of the nice things about Flakes, I guess. Look at this. NixOS rebuild. It's going to build a VM and from a flake. And this is the location of the flake. And now this is going to unpack everything and build it. And I don't know. Let's see. Having both NixOS and Home Manager combined makes it easier to quickly install it on a new machine. But my preference is to have both separate, as my Home Manager configuration changes more often than that of the NixOS one. Yeah, I kind of have it all in the same file, which is you know, pretty just basic, which can result in multiple generations at boot time. Managing the different Home Manager generations in isolations make this way easier for me. Nope. Where is it? Viewing gallery. Sorry, I've just come on. I don't get it. Why isn't this? So the NixOS configuration can be installed. Did something happen? Okay, do you want to allow to be set? Yes. Do you want to permanently mark? Yes. 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 Oh, sorry. So what's going on here? 200. Okay. Home manager, fresh install, Apache license. Okay. So, oh, this is the Flakes tutorial. No, we're not going to do that. Example starter configs. Simple and document config templates to help you get started with NixOS Home Manager Flakes, all the boilerplate you need. Oh, I was trying this once and it all broke. System. I don't know if ChatGPT can already like analyze entire repo. But I said I'm gonna look. Where is it? Okay, here is it. So I want to study this function because I don't understand it well enough. How FP works here, and it would be great to make a simpler or less complex example out of this function. I still haven't done the escape into, yeah. Anyway, it's funny, I come back to this. This Nix function involves a few functional programming concepts packed together: recursion, higher order functions, and attribute set traversal. Is this building? Yeah, look at this. This is still building for the VM. 13 gigabytes. This is too long. This is too much. No, I don't want to do this. Sorry. Okay. I don't want to do this. Not like this. Not like this, please. This is a Nix expression. Recursively reads a directory, returning a nested attribute set showing what's a file or a directory. So, right, this is like advent of code, right? Recursively read a directory and return a nested attribute set, or like a dictionary, showing what's a file or a directory. Collect all file paths into a flat list of strings. Then all of those, so this is like the second step. Then filter and map those paths to build a list of Nix files, excluding certain ones. So we just want Nix files. And then use the result in the imports field, which is commonly used in NixOS or Flake modules, to include many Nix files at once. So yeah. So I kind of want you, let's start from the beginning. So we have a recursively read directory, getDir. So I want the most basic example of a getDir function. And I wanted to I want to start writing code. So a little less complex. So maybe something more simple. So the getDir could read the directory. Let's make an identity function of getDir. Right, returning a nested attribute set showing what's a file or directory. So maybe that's too much for starters. Let's do something like it just returns something, or it returns what's inside a directory, or it returns, I don't know, the most simple thing that it can return that I just want to build from the most the most little, yeah, you know what I mean. And yeah, it depends how much you know. I mean, I guess for some people, functional programming comes easy. For me, it comes very hard because I've been doing this for years and I constantly iterate on the same things. So you're asking for the most minimal version of getDir function so we can build up from the tiniest possible piece. Perfect approach. Let's start super small. So we'll define a function that just takes a directory and returns its contents using builtins.readDir. Oh, we have a builtins.readDir, nothing recursive, no mapping, just a raw result. All right. That's more like it. So let's cd into code, make dir, getDir. Let's make a getDir cd getDir. Right, so we are here. Now we're going to make a getDir is what? Dir builtins.readDir dir. getDir. So we can write, I guess this would be getDir is what? getDir is dir and dir. You can do this, look at this. You can just dir, right? getDir is dir. Can we do this? Why can we cannot do this? Undefined name. But it says builtins.readDir. Why does this not work actually? Let's do sh x nia. Do I have a nia? A shell? Did I have this nia getDir? Wait. sh nia command not found. So nix instantiate eval getDir. So syntax error, unexpected, expecting end of file. Oh, we forgot this. Multiple top level expressions are not allowed. Okay, let's try to do this. So unexpected, expecting end of file. So why is this not actually working? No, this is not working. Look at this. Let's say I have this folder structure. So will this work? getDir. Okay, just let's redo this what you did, the most simple example, but I wanna write it already in a Nix file. I just try to write a simple identity function in a Nix file and it doesn't work. So the first code getDir is, and then the lambda had dir with the body builtins.readDir. So you just write that in a file, right? And let's evaluate it with Nix instantiate. So infinisil has this approach where he explains things and he always starts with the most simple code and then expands on that. So getDir nix dir builtins.readDir. I see. getDir. But Will this work actually? Just dir. This is a function. It takes a dir and returns the result of builtins.readDir. Builtins readDir of the dir. Right. So this is a function. It takes a dir, it takes a directory and returns the result of builtins.readDir directory. This is already the identity-like version you're aiming for. It just returns what builtins.readDir gives you. So let's check out builtins.dir. Actually, we could check on this how to builtins.readDir a derivation subdir when the subdir's path contains a symlink to another derivation's directory. Woola! Oh, look at this. It's interesting. See, Nix is such a rabbit hole. Builtins.dir. No, readDir. Help with writing in NixOS module. Extend call for testing. Hello, alt7 mommy. No, this is not readDir. I thought, is it in NixOS options? You can just call me Jack. Okay, alt7 mommy, I'll call you Jack. Builtins readDir. Is it here? No, it's not here in NixOS options. Is it in Nix manual? So create a test directory, have a directory to test it. Okay, this is the getDir. Okay, make dir my dir. And touch my dir what? A text. Right? No, actually, let's call it a text. Okay. And make dir my dir, make dir my dir subdir. Right? So now we have a text and subdir, subdirectory, 2 directories, 1 file. Okay. So evaluate the function with Nix instantiate. Nix instantiate does not directly evaluate functions. I thought it does. What do you mean? Expects a derivation or fully evaluate expressions. We need to call the function with an argument in another file or wrap it for testing. Create a second file to call the function. Make a file called test.nix. Wait. This is going a bit. So test.nix. Import getDir, my folder. Well, can't I just do it in NixRepl? I forgot NixRepl. Yeah, I forgot. How do I import a file in NixRepl? Load all packages. Build a package from an expression. Start a shell with package. Start a shell. No. inline function and call it in one file. Let getDir in getDir. Oh, I could do that actually. Ah, yeah. So let's do let getDir. Yeah, let getDir. Wait, let's do it like this. Let getDir. In what? In getDir. Where? My folder. My dir. So I guess this would be the simplest one. Let getDir dir builtins.readDir dir in getDir my dir. It's a lot of repetition. So then I would just Nix instantiate it. Nia. Don't I have Nia here? Nia getDir. Okay, we got it. A text is regular, subdir is directory. Oh, regular and directories from built-ins. Wait, where do I find more information about this built-in? This is nice. So now we have it like a, you see, like Nix. A text regular subdir directory. You can find builtins.readDir. Okay. Return the contents of the directory path as a set mapping directory entries to the corresponding file type. For instance, if directory A contains a regular file B and another directory C, then builtins.readDir will return the set regular C directory. The possible values for the file type are regular directory, symlink, and unknown. Oh, it will map a symlink also, and unknown. Read file path. Return the contents of the file path as string. Read file type. Okay. I can do it in REPL with, okay. So it says, even in REPL, I don't built-ins because it's built-ins, right? I don't have to import lib with some like lib functions. Oh, like this, regular and directory. So nice, we have a very simple function now. A text subdir directory. What would happen? What would happen if we in the mydir, in the subdir, we create btext? Okay, let's do it again. And builtins.readDir mydir. Wait a second. Is it not reading? It's not reading. Oh, you see, that's the problem with this. It should be recursive. So that when it reads the subdirectory, it's in the directory. When it's in the directory, call the function again from that directory. That's what we need. That's what programming is about. Right? Because if I will go to mydir, cd mydir, and let's say I run here the REPL, and I do built-ins, Oh no, actually I do. It's readDir my subdir. Look at this. Right, now I get it, because I can't do this. I can't go inside every directory. So that's why. Okay, so that's why. Right. Okay, so I created a basic example, right? But I can see that now, because if I create a file in the subdir, like a b.txt, the function will not read it, right? Otherwise, I would have to go into subdir and run the getDir again so that it can, right, it can find the b file. That's where I guess recursion comes in. So now we have to implement some kind of basic recursion so that once the getDir finds a directory, that calls the getDir from that directory and analyzes again. And if it finds another subdirectory, calls the getDir again. So that's already a slightly more complex. Yeah, you are absolutely following the reasoning like a functional programmer. You've reached the limit of what a non-recursive readdir can do. It only shows one level of the directory. To go deeper into subdir, subdir, sub-subdir, you now need recursion. The goal, getDir myDir to return something like a text regular subdir with a b text regular. That's what we want. This is exactly what recursion allows, right? Let's write the simplest recursive version of getDir together. Recursive getDir. Oh, he did the same thing as infinisil. So this function reads a directory, dir builtins mapAttrs. But now he's using mapAttrs. Reads a directory for each item. If it's a file, return its type regular, right? Because it's a file. You don't go inside a file. If it's a directory, call getDir again inside that directory. Yeah, but this sounds very simple. I kind of said this, but in the code, so dir builtins mapAttrs. What happened? Dir builtins mapAttrs. Name. So, okay, this is a lambda head. Okay. You need to explain me this code a bit better. This is still not clear. So you gotta first see what are the heads and what are the bodies. I want to have an overview on how this function works, right? So because we have several parentheses here and stuff. So first I see dir, which is a lambda head, and then, right, then everything, the rest of this is the body of that function, which tells us how the arguments are going to be, you know, manipulated. How the body of the function is defined, what it is going to do with the arguments. And then we have this mapping, and then inside of the body we have, I guess we have two heads. Wait a second. We have here, yeah, I'm confused, this name type, and then if type directory, then import recursive getDir. Maybe we could make a function that only does this. Like it gives the getDir, but then if it's a directory, yeah, I'm not sure. Yeah, I'm not sure. It's funny, I understand what is going on here, but I wouldn't know how to write this. So this is me trying to learn functional programming now. And you're thinking like someone who wants to truly understand what's going on. Yeah, heads and bodies, what's going on structurally, why we need. Dear built-ins mapAttrs. Wait a second, let's just write it. Sometimes it just helps to, you know, write things out. So, can I just use this function? I don't think so. Dir. Built-ins mapAttrs, name type, okay. Head of the function is dir. This is the head. It defines a lambda, an anonymous function that takes one argument called dir. So yes, so dir okay, this is a lambda function, right? Yeah, we didn't name it though. Did he name it? Where is it? Oh yeah, he does it with let. Right, but he starts with lib. And he names it. Yeah, I don't like how it's teaching me this. Wait a second. Yeah, but let's make this more reproducible. Can we keep the lib in the beginning and, you know, the lib in the beginning and something to output at the end? I don't want to just have a lambda function like this. Maybe we don't have to include now the collecting function and importing, you know, but let's have a workable minimal example using this getDir function. Yeah. Has a getDir, uses lib as a clear output at the end. Basic getDir example. Lib import Nix packages lib. Why does it have import? A basic getDir. So we're going to let okay, in result equals getDir my dir. Okay. Let in result is what? getDir my dir. Yeah, I don't like how this looks like here in Helix. So let what? Let my dir. Okay, we could do like getDir is dir. I don't think this will even work, right? Also here. Eval what? getDir. We have a result code. Of course, it's not outputting anything. Maybe if we add strict, will it change? It does. Look at this. So if we do nia, I don't have nia. Okay, default.nix. Oh, let's call it default.nix actually. Yeah, because then it's automatically picked up. So I'm going to change getDir to default.nix. Right, so now when I write nia, it will just run it. Nia is alias is for nia next instantiate the -- eval. So that I don't have to type it. So nia gets us result code, and nia, if we add the strict, gets us result home stable joy code getDir myDir. So that's some kind of identity function, I guess. This is the basic identity function, right? Result getDir myDir. getDir dir. So now we have here builtins mapAttrs. So we have a mapping function, right? But mapping, it maps attribute sets. So now we have again name, another head, and another head, name and a type. I think this can be anything, name and a type, right? Now if type is what? We said it's directory, and this has to be in double quotes. If a type is directory, well then dir. What is this dir? Else type, else file. This is horrible. Wait a second. Too bad. Let's try Vim. Yeah, it's much prettier. But it's the thing is, builtins mapAttrs. And then builtins.readDir. builtins.readDir dir. In result getDir myDir. Okay, let's try this. Actually, we can do it. I think with Vim is like this. Nia, does it pick up? Command not found. So Vim doesn't pick up the ZSH. Okay, command not found. Nia. Wait a second. Maybe I shouldn't put space. No, it's not. Result code. Result a text file subdir dir. So now we have a different result. First we had stable just myDir, and now we have a subdir as well. But we don't have the B file, so it's not doing recursion. Builtins mapAttrs name type. Yeah, I'm still kind of confused how this works, you know. I'm still kind of confused how this works. It's just not clear. Like it kind of is clear, but what's this going on? So this is exactly the kind of curiosity that leads to deep understanding. Okay. Built-ins mapAttrs name type. If type directory, then dir else file. I mean, this is clear, but it's like I wouldn't know how to write it. This is a function call to mapAttrs. Its structure is mapAttrs function attribute set. Okay, that's the basic, right? We have a mapAttrs mapping. Okay, we have a mapping function, mapAttrs. A function. I guess you could make a simple example out of this, like mapping mapAttrs, and function would be like +2, and attribute set would be an attribute set of numbers, and then you would just add 2 number to each member of the attribute set. This returns this, so think of it like a dictionary of file name, file type, file name, file type, name type. So this is an anonymous function that takes 2 arguments. I thought this is not an anonymous function. Oh, it is. No, I thought it's getDir. This means name key in the attribute set, like a text or subdir, and type value in the attribute set. What's the time? Hour and 17 minutes. Yeah. So when mapAttrs walks over the attribute set, it gives this function each name and type. This walks through each entry in the attribute set and replaces the values using your function. The key's name stays the same. The value becomes whatever your function returns. Builtins.readDir myDir returns. Then mapAttrs applies your function to each item. First entry, name a text, type regular, result file. Second entry, name subdir, type directory, result dir. So the output is a text subdir. For each file or folder in this directory, keep this name the same, but label it as either dir or file, depending on what it is. So for each file or folder in this directory, maybe it's ridiculous. Maybe I'm too long at this. I don't know. Like, if someone is even watching this, how clear is this? It is clear, but how fluent? Yeah. For each file or folder in this directory, keep the name the same, but label it as either dir or file. If type directory, then dir, else file. But I think this is clear, but it's interesting how it's, so this whole thing is mapped. It's chained together with this thing, builtins.readDir. Yeah, I think the problem comes from, you know, I understand what each part of this is doing, but when you say, you know, looking at the code, mapping this function to the attribute set. But there is no attribute set. The attribute set is readDir, like builtins.readDir from some attribute set. Yeah, I'm kind of not sure how to phrase this. To try this in xREPL, builtins mapAttrs name type something, output. Okay, there's a couple of, to try this in xREPL. Maybe we could try this in xREPL. So builtins, I can just do this. mapAttrs and name type and something. What is this something? And now what? X equals A, y equals b. Oh. I see. So built-ins mapAttrs, name, type, something. Now change something to type. Name, type, type. Name, type. Now he changed it to type. What is it doing, man? Name, type, type, and then what? Then we do the same thing. X is A, Y is B. Wait a second. So mapAttrs name type something. Built-ins map. Wow. I like this making really a lot of examples. Built-ins mapAttrs name type. Name type. Okay, name type. Oh, interesting. If type is what? If type is B, then we can write B, right? Else other. Partially applied premop mapAttrs. Oh, interesting. Built-in mapAttrs. Name type. If type is B, then B. Else other. Now we can have to apply this, I guess. X is A, Y is B. So X is other and Y is B. Because we said if type is B, then B, else other. So Y is B. If type is B. Would you like a visual sketch of how mapAttrs walks over a set? Or should we now use this understanding to start running recursion? No, I'd like you to make more such examples, maybe with numbers or something. So that, like you did just now with B and stuff, can you make more examples? So built-ins mapAttrs name and type. If type is B, why am I confused with this? If type is B, then B, else other. If name is B, then B, else other. So doubling numbers, built-ins mapAttrs. Okay, let's do built-ins. Built-ins mapAttrs name and the value. So this is a function that will be applied to something. So we have a name and they have a value. So I guess we cannot just have a value, right? That, and then you double the, why cannot we have like a value and we double the value? But we have to have a name because we're going to give it an attribute set. Oh, that's why you need an, because it's mapAttrs. Because it's mapAttrs, we are giving it a function that has two heads. Because this is mapAttrs, right? So built-ins mapAttrs, use mapAttrs. So apply function f to every element of attribute set. For example, built-ins mapAttrs name value, value times 10. So we cannot just have a value. That will work only if we had map, builtins.map. If we had builtins.map, you could write double. I guess we could do that. Wait a second. We have builtins.map, and we have a value, and a value times 2, right? And now I'm gonna give it a value of but it's attribute set. No, this won't work actually. Expected a list but found a set, right? Because this is not mapAttrs. Built-ins map and value, value, the head, or let's just call it x times 2. Right, so that's like simple mapping function that doubles a number. And now we have a list. I think in Nix, what is it? Without comma. 1, 2, 3, 4, 5. Right, this works. Built-ins map, and then we have a double function, and then we give it a list of numbers. So 1, 2, 3, 4, 5 is 2, 4, 6, 8, 10, and all of the members of the list are doubled. But now we have built-ins.mapAttrs. So now we cannot just do x because it expects an attribute set. So mapAttrs, how would we do this? I guess we have a name or a value. Maybe we could do name and value. And the function will be value times 2. Can we do it like this? An attribute set. A. So that will be, let's try A equals, would be, can we do it like this? A1, B2. Like, I think I have to, yeah, I have to write semicolon. Okay, I do it like this. B2. Oh, it works like this. Built-ins, let's do more. Built-ins mapAttrs name value, value times, let's do it again, value times 2. So it's a partially applied premop mapAttrs. I guess you could name it like that. Double attrs. Double attrs is built-ins mapAttrs and name value and value times 2. I could name it like this. Double attrs, and then I could do A is 1, B is 2, and it also works like this. Double attrs. A is 2, B is 4. So this is a basic example with numbers. Name value, value times 10, A1, B2. But we don't have to have double quotes. Oh, it's interesting. So I put double quotes here. I don't have to do them. So maps, okay, So mapAttrs applies a function to an attribute set. A map applies a function to a list. Okay, this is kind of a little more clear now. Name is AB, value. We're doubling the value. Example, add prefix to keys, keep values. Built-ins mapAttrs. Oh, what is this? Name was toString value. Apple was 42, orange was 99. Just playing with both the key and value. Conditional replacement. Built-ins mapAttrs, name value. If value greater than 10, then big, else small. Of course you can do stuff like this. Built-ins mapAttrs. Right, we have a name and a value. And now if value, can we do it like this? If value greater than, wait a second, I'm just going to do it here. If value greater than 10, then boo. Then boo. Else blah. Yeah, so this is the function, and we're going to apply it to a attribute set. An attribute set is going to have, let's say, A is 5, B is 11, C is 120, and D is 2. Right? So now we have blah, boo, boo, blah. Right? A was, so a value greater than 10, then boo, else blah. Okay, that's not bad. So use the key to influence the value. Built-ins mapAttrs name. If lib has prefix x, then, oh, this is introducing a lib. If lib has prefix x, then starts with x, else other. Wait, I need a. Yeah, I'll be back. Use the decision depends on the key, not the value. Chain logic. Built-in, this is nice. Built-in mapAttrs. Again, we have a, okay. So it's, I guess it's important to do more of these. So we have a function and it's applied to an attribute set. So name value. If value less than 0, then negative, else if value, okay, this is basic. This is not complicated. Name, value, and then you do something. Or flatten something like a NixOS structure. What do you think? What would be the next level of complexity? Add recursion, right. Right now you only look at the first level of a directory of attributes set. Recursion lets you go into nested structures. If a value is a directory, call mapAttrs again inside it. Return full paths. Collecting values into a list. That's what he did. And then filtering. And use all of the above together. So it's kind of it's a very simple example, but it does a lot of the functional programming things, right? Recursively collect paths, filter, remove this, return full path. And first read the file, read the directories. But what are you adding here? Let and walk builtins.readDir myDir. So now this, I guess this is clear. Builtins mapAttrs. Let's look at this again. I'm probably so boring, but let getDir, dir. Okay, dir is the head. Oh, first we only used it like this. We didn't use the dir. Okay, I kind of get the idea of built-ins, you know, we began with built-ins in the Nix REPL. You start with a built-ins function, in our case, mapping attribute sets, right? You pass in you define some kind of a function with, let's say, 2 heads, and you apply it to an attribute set. But what about this head now that we have before the built-ins? So now you are naming a function, a walk here, for example. You're using rec also, okay, but that's not important. But you have a set, a lambda head called set, and then built-ins mapAttrs. In our previous getDir example, you had a dir head, a dir lambda head, and then the built-ins mapAttrs with a function and attribute set. Why this head before the builtins.map, right? Thousands of questions. I literally just asked something. Why the lambda head before the builtins.map address? I'm trying to understand this now. I get it. We did simple examples with built-ins, the name of the function, and then the function body, and then the attribute set on which this function body, is being applied, right? But now we have a lambda head before the built-ins. Why do we sometimes write dir and then builtins mapAttrs? Right, instead of starting directly with builtins mapAttrs. Right. You're defining a function. This is a difference between calling a function. You're evaluating mapAttrs immediately. Right. we have built-ins mapAttrs, name, val, some kind of operation that we're going to do. Let's say double a number, and then we give it an attribute set 1 and 2. We double 1 into 2, we double 2 into 4, right? So this runs now on the given attribute set. But you're making a new function that takes some argument like a path and then returns mapAttrs. Dir, built-ins mapAttrs, name and a value. And builtins.readDir. This creates a function like a variable you can call later. Here's a function called getDir. It takes dir and uses built-in mapAttrs on the result of builtins.readDir. Oh, the first dir is the lambda head, just like x or n in other languages. Writing x, define a function that doubles its input. The outer function takes a dir. Inside it calls builtins.readDir. Yeah, okay. I guess it's still same level of abstraction. It's just, I guess this was confusing because there is parenthesis here, but this is going to output, I guess builtins.readDir outputs an attribute set. Right? So if I go to Nix repo and I do builtins readDir dir. So what's my dir? It's my dir. So I get this built-ins. So I do get an attribute set. Right. Before, in our most simple examples, we were just basically applying some kind of attribute set with numbers, and then here we doubled it, or we said if the number is lower or higher, we're gonna write this foobar or whatever. But now, instead of giving it an attribute set, we have a function here that reads it and outputs. So readDir does output an attribute set. It calls builtins.readDir, then it maps over the contents using a second lambda. So builtins, okay, so that's why we have dir. But what if we didn't have a dir here? Oh, then the function, we could do that, I think, but then it's then we would have to always builtins mapAttrs, right? Name, value. Okay, type. Now, if type is what? If type is directory, then dir, else file. Then file. Now builtins readDir. Now I would have to write like this, I guess. My dir. Now we don't have to write dir at the beginning. I think this should work. It does work. Isn't this cool? So basic. But builtins.mapAttrs maps this function here to this attribute set. But it's not an attribute set yet. It's a, well, it's a function that outputs an attribute set. which attribute set. So we're not passing the attribute set, but builtins.readDir reads the contents of the directory and outputs the contents as a Nix attribute set. It's funny, this is something what I saw on Nix, like, let's say you import a project and it has a certain kind of file directory structure. So you could import that too as a Nix file, the directory structure itself. That's really cool. So basically your directory structure maybe becomes not so important. If you could scan it, yeah. I think there are some Nix tools that do this. But what's the difference between readDir and those tools? Maybe they're more complex. So now we have this. All right, the outer. So dir, outer lambda head, built-ins mapAttrs is function application. Right, we're now applying the function. Name type is the inner lambda head for each file in the attribute set. That's the inner lambda, that's the inner type. So these are two heads. Now, if type is the directory, then dir, else file. Attribute set the map is applied to. Right. Now, we did use it like this, but this is really not practical. That means I have to type it every time. But if I give it a name, well, let's look at this again. Oh, now this is using the let expression. So what's the difference between okay, sure. So now we have getDir, dir, built-ins mapAttrs name type. If type directory, then dir, else file. Built-ins. Now this is being applied to this built-ins.readDir dir. And let this in what? Result is getDir, my dir. Yeah, it's a little clearer now. Would I be able to write it? Maybe. Yeah, I think now I would be able to write it. Let's walk through this step by step. We'll start super small. A function that returns the directory contents. Try writing this. Step 1, path, built-ins.readDir path. Can this work even? What's the time? Hour and 51. I think that's enough. I'm going to do this tomorrow too. I think it was not bad, this session. Just very basically studying getDir. Studying Nix language. Yeah, I'm going to stop. So thanks everyone. I have a bit busy day ahead. But I like this. It was fun. It was fun. Okay. Bye-bye. Have a nice day. Have a nice night.